Hello guys, in this lecture we show the reaction of alcohol. In this reaction we will see the dehydration of alcohol. Dehydration of alcohol. Now firstly we show the dehydration. What is meant by dehydration? Dehydration means removal of water molecule. Dehydration means removal of water molecule. Okay. This water molecule is removed from alcohol. This water molecule is removed from alcohol. That means here we consider this is a alcohol. Generally this alcohol is considered here. Then this hydroxyl group is directly attached to this carbon atom, and these two carbon atoms, the remaining valences of these two carbon atoms is valenced by any hydrogen or any alkyl group. This is a one hydrogen is written here. That means if the hydroxyl group is directly attached to this carbon atom or any functional group is directly attached to the carbon atom, then this carbon atom is considered as a alpha carbon. And adjacent to that of alpha carbon there is a beta carbon is here. Okay. Then this is a alcohol. This alcohol undergoes the dehydration reaction. This alcohol it undergoes the dehydration reaction. That means from this alcohol there is a elimination of water molecule. There is a elimination of water molecule. By the elimination of water molecule eliminated is written here. Then there is a formation of alkene. There is a formation of alkene. Okay. This is a general reaction of alcohol. Alcohol, it undergoes dehydration reaction, then it forms the alkene. But this reaction is not happen easily by absence of any reagent. Okay. Because this alcohol contains the hydroxyl group, and this hydroxyl group and carbon, the bond between carbon and hydroxyl group, it should be break down, and similarly the bond between carbon and hydrogen, it also break down. Okay. Therefore, the water molecule it should be eliminated, but this reaction is carried out by using a dehydrating agents. This reaction is carried out by using dehydrating agents, or it also known as a dehydrating reagent. Then firstly and mostly used dehydrating agent, it is a concentrated H2SO4. Either we can also use the H3PO4 phosphoric acid. Either we can also use H phosphorus pentaoxide, and other we also use Al2O3. It is called as a alumina. Okay. Then this is a dehydrating agent. These are the dehydrating agents. By using this dehydrating agent, which out of these, what a dehydrating agent is used in this reaction. Then this dehydrating agent, it remove the water molecule from the alcohol, and then it forms their respective alkenes. Then it forms their corresponding alkenes. It having a same number of carbon atoms which is present in alcohol. That means the number of carbon atoms, if in case of alcohol there are two carbon atoms are here, then similarly two carbons are also present in alkene. Okay. Then this is a dehydrating agent. By using this hydrating agent, that means we can also use the concentrated H2SO4. By using this concentrated H2SO4, then alcohol get converted into alkene. Okay. But we goes towards the alcohol. Alcohol, it is a three types. There is a primary alcohol, there is a secondary alcohol, and there is a tertiary alcohol. Okay. Then by changing the type of alcohol, if primary alcohol is, it undergoes dehydration reaction by using concentrated H2SO4, or if the secondary alcohol is undergoes the dehydration using concentrated H2SO4 and tertiary, it undergoes dehydration by using concentrated H2SO4. And if primary, secondary and tertiary alcohols is used, then if the type of alcohol, it should be changed by changing the concentration of H2SO4. Once again, I will repeat it. If the type of alcohol, it should be changed by changing the percentage of or concentration of H2SO4, because the concentration of H2SO4 which can be used is totally depends on the which type of alcohol is used here. If the primary alcohol is used, there is a 95% of H2SO4 is also used. If the secondary alcohol undergoes the dehydration reaction, then 60% H2SO4 is also used. And if the tertiary alcohol, it undergoes dehydration reaction, there are 20% H2SO4 is used for this reaction. Okay. As well as for this reaction, there are a temperature is also required. Okay. What is the role of temperature in this reaction? Because there are two bonds are breakdowns here. Okay. Then due to breaking this bond, the temperature is necessary in this reaction. If the 95% concentrated H2SO4 or 90% of H2SO4 used with primary alcohol, the temperature is 443 Kelvin. The temperature is 443 Kelvin. Okay. After that, the 60% H2SO4 is used here, then temperature is 373 Kelvin. And if the 20% H2SO4 is used, then temperature it should be decreases at 363 Kelvin. Then temperature is also variable, as well as concentration of H2SO4 is also variable, which depends on the which type of alcohol is used in this reaction. Okay, guys. Then we comes towards the example of this reaction. Okay. Now we take. We can write here, if primary alcohol 95%, temperature is 443 Kelvin, 443 Kelvin. Secondary alcohol 60% H2SO4 is used, temperature is 363 Kelvin, 73 Kelvin. And if the tertiary alcohol is reacted with 20% H2SO4 at 363 Kelvin. This is a temperature as well as percentage of concentration of H2SO4 is used with alcohol, their respective alcohols. We consider here there is a CH3, CH2 OH. This is a ethanol, and this one is a type of primary alcohol. This ethanol is reacted with concentrated H2SO4, but this is a primary alcohol. The primary alcohol, if the primary alcohol is used, then 95% concentrated H2SO4 is also used, and this reaction is carried out at 443 Kelvin. This reaction is also carried out at 443 Kelvin. Okay. Then this hydroxyl group is attached to the this carbon atom. Therefore, this carbon shows the alpha carbon atom. Adjacent to that of alpha, this carbon it is a beta carbon atom. Okay. Then water molecule it also eliminated. Then one hydroxyl group and beta hydrogen it should be eliminated, and double bond is formed in between these two carbon atoms, and there is a formation of alkene plus H2O. It should be eliminated, and it forms the alkene. Okay, guys. But in this reaction, the role of 95% H2SO4 or 60% H2SO4 as well as 20% H2SO4 is that it acts as a protonating agent. It acts as a protonating agent. Firstly, this H2SO4 is act as a protonating agent. That means this is a H2SO4. The mechanism, in this mechanism, we will clear that all things about the H2SO4, about the primary alcohol, about the heating. Okay. Then this H2SO4 acts as the strongest acid, therefore it donates the H plus ion easily. Then we consider here this is a CH3, CH2, this one is the OH. And this H2SO4 acts as the strongest acid, therefore we also consider only H plus ion. Okay. this H2SO4 is strongest acid, it donates the H plus ion. Therefore, this H plus ion is considered considered as a H2SO4. Okay. From this alcohol, the oxygen carries the lone pair. By using this lone pair, the oxygen, it having a new bond between oxygen and hydrogen atom. That means in this alcohol, the oxygen atom and hydrogen atom, therefore no bond, it should be generated, and there is a formation of protonated alcohol. There is a formation of protonated alcohol. One lone pair is as it is here, and oxygen shows the positive charge. Oxygen shows positive charge. Okay. After protonation, this protonation process, it is a reversible process as well as it is a fast step process. Okay. That means the mechanism in this is the first step. In first step, there is a protonation of alcohol is here. Protonation of alcohol is here. In first step, alcohol undergoes the protonation. That means the new bond it should be generated between oxygen and H plus ion, and this is a reversible process, because after protonation, by elimination of H plus ion, then also we get the alcohol. Okay, then this is a fast step process. Okay. After that, this is a formation of water molecule, and water molecule it is a base leaving group. Therefore, in second step there is a formation of carbocation. Okay. In second step there is a formation of carbocation. That means there is here, second step is here, then CH3, CH2. This is a protonated alcohol which is formed in step first. Okay. This oxygen is an electron deficient species and it carries a one lone pair. By using this lone pair, this bond, that means the electron pair which is present in bond between carbon and oxygen atom, it is delocalized on the oxygen atom, and in this water molecule it should be eliminated. And after elimination there is a formation of a carbocation. Okay. Then the title of second step, it is a formation or removal of water molecule and formation of carbocation. Removal of water molecule and formation of carbocation. Okay. After formation of carbocation, then we goes towards the third step of this mechanism. Here it is a hydrogen, carbon, hydrogen and hydrogen. And this CH and this CH is here with a positive charge on this carbon atom. This CH3, CH2 is written in this form. Okay, for better understanding. This CH3, CH2, there is a formation of carbocation. This formation of carbocation, which is formed in second step, it is used in third step. Then, after formation of carbocation, there is no any reagent is remaining for reaction or for reacted with the carbocation. No any reagent is here, because only one reagent, that means the concentrated H2SO4, that means the H plus ion, it is already involved in this step. Therefore, no any kind of reagent, no any kind of remaining agents is here. Therefore, this carbocation, it undergoes the rearrangement reaction. That means this carbocation, adjacent of that, this carbocation, there is a hydrogen is here. For this carbocation, it having a electron deficient species. To stability of this carbocation goes on increases by gaining of electron or by donation of electron to this carbon atom. Okay, that means to this positive charge carbon atom or carbocation. Therefore, the bond between carbon and hydrogen atom, we consider this bond, we consider also this bond, or we also consider this bond. Out of these three bonds, we can consider only one bond. Then this bond or this bond pair, lone electron pair, is delocalized in between carbon atom and carbocation. After delocalization, there is a formation of H plus. Then this is a single bond get converted into double bond. Plus H plus is also generated, and this H plus, that means we will use in first step, that means this H plus is coming from the concentrated H2O support. That means in case of dehydration of alcohol, the concentrated H2O support, it acts as a dehydrating agent. That means it acts as a protonating agent. That means in first step, by using H2O support, the alcohol, it undergoes protonation. After protonation, removal of water molecule, then it forms the carbocation. And after formation of carbocation, there is a rearrangement reaction is also possible. Because of this rearrangement, there is a formation of alkene is also possible. But in this reaction, in first step, there is a H plus ion is also involved in this reaction, and after formation of alkane, there is a H plus ion is also generated. That means the H plus ion is also involved in this reaction, and H plus ion is lastly it is also remains as it is. That means the concentrated H2O support is act as a catalyst as well as it act as a dehydrating agent. Okay guys, this is a mechanism of the dehydration of alcohol. Okay, but in this reaction we will consider the primary alcohol, secondary alcohol and tertiary alcohol. Depending on it, which type of alcohol, we can use the concentration of H2O support as well as we also use the percentage of, as well as we also use the temperature. Okay. Now we here consider CH3CH2OH. It undergoes the dehydration reaction by using 95% H2O support at 443 Kelvin. Then it gives, there is elimination of water molecule. Then this is a alpha, and adjacent to that alpha carbon, we consider the beta carbon is here. That means the alpha, the elimination reaction, it should be happening on in between two carbon atoms, that is a alpha and beta carbon atom. Therefore, this reaction is also known as a alpha beta elimination reaction. This reaction is also known as a alpha beta elimination reaction. Okay. Then because from alpha carbon there is a hydroxyl group is eliminated, and from beta carbon there is a beta hydrogen which should be eliminated, and then it forms their respective alkenes. Plus H2O is also formed. This is a primary alcohol. And if the secondary alcohol is here, that is a propanol, it undergoes dehydration reaction by using 60% H2O support, and temperature is also reduced at 73 Kelvin. Okay. And similarly, their respective alkenes are formed. That means this one is a alpha carbon. There are two beta carbons are here, but these two beta carbons are present in the same atmosphere or present in a similar form. Therefore, this one is a beta, this one is beta. The beta hydrogen it should be eliminated from this carbon or from this carbon atom. There is a no any change in formation of proton. Okay. Then from this carbon atom there is a double bond it should be formed between these two carbon atoms, and beta hydrogen it should be eliminated from this carbon atom. There is a double bond is also formed in between these two carbon atoms. Okay. Then there is a formation of CH2 double bond C H, then CH3 is here. There is a formation of alkene plus water molecule, it should be eliminated. Okay. Then now we take the tertiary alcohol. If tertiary alcohol undergoes dehydration reaction by using 20% H2SO4 at 363 Kelvin, then it forms their respective alkenes. Okay. Then this one is a alpha carbon, this one is a beta, this one is a beta, and this one is a beta carbon is also here. Then three beta carbons are here. That means the beta hydrogens are here. Okay. Then from this carbon atom beta carbon there are three beta carbon hydrogens here. From this three hydrogen, from these three beta hydrogens are here. That means the one hydrogen it should be eliminated from this or from this beta carbon atom. Okay. By the elimination of beta hydrogen and hydroxyl group, there is a formation of their respective alkene plus H2, it should be eliminated. Okay. Now we focus on these three reactions. This is a primary alcohol, this one is a secondary alcohol, and this one is a tertiary alcohol. Okay. If primary alcohol undergoes is reacted 95%, secondary is 60%, and tertiary is 20%. Okay. Why concentration as well as temperature is variable in primary, secondary, and tertiary alcohol? Because the order of dehydration of the alcohol, the order of alcohol with respect to dehydration is that means this is the most important point. The order of alcohol with respect to dehydration reaction is that a tertiary alcohol is more easily dehydrated than secondary alcohol and than primary alcohol. Okay, then due to this order of alcohol, then tertiary alcohol it is a more easily dehydrated. Therefore, this is a 20% H2SO4. That means by using 20% H2SO4 or by using a lower concentration H2SO4 as well as lower temperature, the tertiary alcohol got easily alkene. Then after that, the secondary alcohol is also tough than the tertiary alcohol for the dehydration. Therefore, the concentration of H2SO4 is slightly increases as well as temperature is also slightly increases. Then there is a formation of their respective alkenes. And primary alcohol, it is a much slower to dehydration reaction because the concentration and temperature both are it stay at higher level, that means 95% and 443 Kelvin. Okay, the mechanism is similar to primary, secondary, and as well as tertiary alcohol. It is a similar to all types of alcohol. Okay, but the one is the most important point is that in this case or in the case of secondary alcohol, this example with right here, it is a symmetrical alcohol. And if the asymmetrical alcohol is also reacted with or it undergoes dehydration at 60% H2SO4 and 373 Kelvin, then it also forms their respective alkenes. But if the asymmetrical alcohol is used here, then there is a formation of two types of products. Out of these, one is a major product is formed and another one is a minor product is also formed. The major and a minor product is decided according to Zaitsev rule. Okay. Now we see about the Zaitsev rule. Okay. Okay. Then now we consider here CH3, CH3. This is a propan 2OL. It undergoes the dehydration by using 60% H2SO4 at 373 Kelvin. Then it forms only one product, that is a CH2, double bond CH and CH3. That is a propene. Because the alpha hydrogen, it should be eliminated from hydroxyl group with hydroxyl group. Therefore, this one is a beta, this one is also beta. Both beta carbon atoms are present in similar atmosphere. Now, this is an example of symmetrical alcohol. Now, take here the example of asymmetrical alcohol. Okay, this is a butane 2OL. This is also secondary alcohol. This secondary alcohol undergoes the dehydration reaction by using 60% H2SO4 at 373 Kelvin temperature. Now, in this case, there is a formation of two types of products because the hydroxyl group is directly attached to this carbon atom. Therefore, this carbon shows the alpha carbon. Adjacent to that of carbon, there is a beta, and this one is also beta. Now, this is named as a beta 1 and this is a beta 2 for better understanding. Then hydroxyl group and one beta hydrogen. Now we consider this beta 1 carbon. the hydroxyl group and beta hydrogen from the beta 1 carbon atom, it should be eliminated, and there is a formation of double bond between beta 1 and alpha carbon atom. That means there is a formation of CH3, CH2, CH double bond, CH2 is also formed. Okay. Double bond is here, that means the hydroxyl group and beta hydrogen, it should be eliminated from beta 1 carbon atom. Now consider the beta 2 carbon atom. Then this one is also beta carbon atom, because dehydration reaction is commonly known as a alpha beta elimination reaction, or it is also known as a 1,2 elimination reaction. 1,2 elimination reaction. Then beta hydrogen is eliminated from the beta 2 carbon atom and this hydroxyl group. That means the double bond is formed in between this alpha carbon and beta 2 carbon atom. That means the respective product is that this CH3, CH double bond CH and CH. Okay. Then there are two types of products here. This is a butene or but 1-ene. This one is a but 2-ene. Out of these two products, the but 2-ene, it is a major product. Sorry, but 2-ene, it is a major product, and butene, it is a minor product. Then this minor or major product is decided according to Syatzeff rule, or it is also known as a Zaitsev rule. Syatzeff rule, or it is also known as a Zaitsev rule. Okay. Now, what is a Syatzeff rule or Zaitsev rule? The Syatzeff says, in case of elimination reaction, in this elimination reaction, there are majorly two types of reactions is here. One is a dehydration reaction, in that the water molecule is also eliminated, and second reaction in case of hydrohalogenation reaction. These two reactions, that means elimination of water, it is known as a dehydration, and elimination of HX, it is also known as a dehydrohalogenation reaction. Okay, this is a commonly included in elimination reaction. That means in elimination, that means in dehydration or dehydrohalogenation reaction, the beta hydrogen, it should be eliminated and forms their respective alkenes. The major product is that which contains a more substituted carbon atom. That means if the beta hydrogen, that means in dehydrohalogenation reaction or in dehydration reaction, the alkenes are formed. The alkenes are formed by the elimination. Alkenes are formed by the elimination reaction, which contains a greater number of carbon atoms. That means this hydroxyl group is eliminated with H plus ion. This hydroxyl group and beta hydrogen from the beta 1 carbon atom, it should be eliminated. That means the double bond is formed between alpha and beta 1 carbon atom. And secondly, the double bond is formed in between alpha and beta 2 carbon atom. Out of this, the double bond, it should be formed between alpha and beta 2 carbon atom, which having a major product. Because these beta 2 carbon atoms, which contains a 1 alkyl group, and this CH3 group or beta carbon atom, it does not attach to any alkyl group. Therefore, this carbon, to this carbon atom, one alkyl group is attached, or one carbon atom is also attached. Therefore, this carbon atom, that means this beta 2 carbon atoms, having a greater number of alkyl groups than beta 1 carbon atom. There is no any carbon atoms or no any alkyl groups is attached to this. Therefore, it is a less substituted is also here. Then this carbon atom, which contains a 1 alkyl group, 1 methyl group. Therefore, this carbon atom is considered as a more substituted carbon atom, and that means the beta, that means the alkenes is also formed from the elimination of beta hydrogen from the beta carbon atom, but this beta carbon atom which is a greater number of substituent or it is a higher number of substituents is attached to this carbon atom. Okay, according to this Zaitsev rule or Zaitsev rule, there is a 2-butene, it is a major product, and butene, it is a minor product. Okay, then this Zaitsev rule or Zaitsev rule also we studied in 11th standard in alkene topic. There is a preparation of alkene. In this point, this Zaitsev rule or Zaitsev rule is also included by using this also example here. Okay, now this is a asymmetrical alcohol is here. If the asymmetrical alcohol is undergoes dehydration reaction, then there is a formation of two products. Out of these two products, one is a major and another one is a minor product is here. The major product is decided according to Syatzeff rule or Zaitsev rule. What is the Syatzeff rule or Zaitsev rule? The Syatzeff rule is that in case of elimination, and in that of elimination, in dehydrohalogenation or dehydration reaction, the alkenes are formed which contains a greater number of carbon atoms. Greater number of carbon atoms. This is a Syatzeff rule or Zaitsev. Okay guys, this is some examples. Okay, then another example we also studied here. Easily we consider the example, that is this example is here. The IUPAC name of this example is one number is here, 1-methyl cyclohexanol. This is a tertiary alcohol because this alcohol is attached to this carbon atom. This carbon contains this carbon, second carbon, and this one is a third carbon atom. Therefore, it is a tertiary alcohol. If the tertiary alcohol, it undergoes the dehydration reaction by using a 20% H2SO4. By using a 20% H2SO4, and temperature is that 363 Kelvin. Okay. Then by using 20% H2SO4, the double bond or alkene is also formed, but this hydroxyl group is attached to this carbon atom. Then this carbon shows the alpha. Adjacent of this alpha carbon atom, there are 3 beta carbons are here. Then this one is a beta 1 is here because this is a CH3 group. That means the methyl group is here. Then this is a CH2 group. That means it is also beta 2. And this one is also CH2. This one is a beta 3 carbon atoms. Okay. Now beta hydrogen it should be eliminated for preparation of alkene. Then according to Syatzeff rule, the alkenes is also formed it having or from the carbon atom, from the beta carbon atom which having or which contains the greater number of substituent, greater number of alkyl groups. Okay. Then in this beta 1 carbon atom, there are only one beta carbon is here. There is no any other substituent attached to the beta 1 carbon atom. But in case of beta 2 and beta 3 carbon atoms, there are similar number of substituents is attached to the both carbon atoms. Okay. Now we consider beta 2. Beta 2 contains 1, 2, 3, and also beta 3 contains 1, 2, 3 carbon atoms. That means the beta 2 and beta 3 carbon atoms is similar here. Therefore, out of these two beta 2 and beta 3 carbon atom, we consider only one beta carbon atom. Okay. Then the double bond is also formed because if the asymmetric alcohol is here, it undergoes dehydration reaction. There are two types of alkenes are also generated, or it also forms. Out of these, one is a major and another one is a minor product. Okay. Then there are two products are formed here. Then firstly we consider the elimination of hydroxyl group from this beta 3 carbon atoms. Okay. We also repeated the beta 2 and beta 3. These two beta carbon atoms are similar in number of substituents. Okay, that means for beta 2 or beta 3 carbon atoms, both carbon atoms contains the same number of substituents. Okay, therefore out of these two beta carbon atoms we consider the only carbon atom. Okay, now we consider this carbon atom. This carbon atom contains the two hydrogen atoms. Out of these two beta hydrogen, one hydrogen it should be eliminated with hydroxyl group. That means the double bond is formed between alpha and beta carbon atom. Then if product is that, this one, the double bond it should be formed here. Okay, that means the cyclohexene is formed. There is a cyclohexene is formed. Okay. Then similar, by using beta 2, there are similar products here, but double bond is shifted in between these two carbon atoms. That means this one is also cyclohexene. This cyclohexene and this one is also cyclohexene. That means from beta 2 and beta 3 carbon atoms, similar product is formed. Therefore, we consider only one type of carbon atom. Then after that, we consider the beta 1 carbon atom. To the beta 1 carbon atom, there is a CH3 is here. Then this hydroxyl group, and out of this beta carbon atom, okay, that means this is a CH3 is written right here. Then one hydrogen and hydroxyl group is eliminated. That means the one water molecule is also eliminated, and there is a formation of double bond between this OH group is also eliminated. After elimination of H plus ion, the bond between carbon and hydrogen atom, that means this is a H2 and this hydrogen is here, one hydrogen, CH2, CH and CH. Hydrogen it should be eliminated, that means the bond, the electron which is present in this carbon and hydrogen bond, it is shifted in these two carbon atoms, then double bond is formed here. Okay, then name of this compound is a methylene cyclohexane. Methylene cyclohexane. Okay, then there are two products are here. Out of these, one is a major product and another one is a minor product is here. Out of these two products, the cyclohexene is considered as a major, and methylene cyclohexane is considered as a minor product. Okay, according to Zaitsev rule, the double bond it should be our alkene is formed from the beta carbon atom which contains more substituent. Here we consider this carbon atom. This carbon atom contains 1, 2, 3, or 1. We consider firstly this one is a one carbon atom, and to this beta carbon atom there is no any kind of alkyl group is attached to beta 1 carbon atom. Here one alkyl group is here. Here no any alkyl group is present. Therefore, this beta carbon atom which is act as a more substituent or greater number of substituent carbon atom. That means by the formation of double bond in between these two carbon atoms, there is a formation of cyclohexene, and this cyclohexene is considered as a major product, and methylene cyclohexane is also considered as a minor product according to Syatzeff rule or according to Zaitsev. Okay guys, this is a preparation methods of alkene from alcohol. That means the reaction of alcohol. In this case, if the alcohol it undergoes dehydration reaction by using concentrated H2SO4, then it gives their corresponding alkenes. But the number of the number of carbon atom which is present in alcohol is similar with the number of carbon atoms which is present in product. That means which is present in alkene. Okay guys, this is the dehydration of alcohol. Okay guys, thank you.